All right, my friends, for problem 4, I'm going to demonstrate 2 ways to do this problem. There's a standard way that I think most people did, and then there's a shortcut. And then for the bonus, I'll probably lean on the shortcut method, and wish me luck, because I do have a tendency to screw up a mundane detail on the bonus. So let's hope I can figure out the bonus. Anyway, so let's see. So first, let's show you the standard method. This is what most people did, simply because this is what I demonstrated in the video. So the standard method would be to, first of all, figure out what kind of model, so you're diagnosing. So to get from -1 to 0, you'd have to add 1, and then from 0 to 6, you'd add 6. Boy, from 6 to 17, you'd have to add 11, and then from 17 to 33, you'd have to add 16. Since your first row of differences is not constant, you're definitely not dealing with a linear model. And then now looking at your second row, so to get from 1 to 6, you'd add 5, 6 to 11, add 5, 11 to 16, you'd add 5. And so since your second row of differences is constant, that would imply that your model is going to be quadratic, so, or degree 2. So there we go. So we know what kind of model we're dealing with. And I'll just kind of copy that up here. So we know that we're dealing with okay. Now to figure out what the A, B, and C values are, we're going to use the fact that A sub 1 is -1. So that means that when n is a 1, your term is -1. So A sub 1 being -1, if you were to put this information into this model, when you're putting 1 in for n, it should spit -1 out for the term. So it would look like this. And then you could simplify it to that. And you have 3 unknowns, which means we're going to need 3 equations in order to solve it. And so that's where you'd probably move to using A sub 2 being 0. So since A sub 2 is 0, that would give you, when you plug 2 in for n, your formula should spit 0 out for the term. And so simplifying it, it would look like that. And then you just need one more. You could use any of the terms, but it makes sense to me to try to keep your numbers low, so to go to A sub 3. And so A sub 3 was 6. So that would mean if you plug in 3 for n, it should give you 6 out up here in the model. So there we go. So here's my system of equations that I'm going to work with. And now I just need to use the process of, some process. Some people do substitution. I highly recommend elimination. And I recommend eliminating C if you do that. So there's lots of room for variety for how you solve it. It's just a matter of picking something that doesn't torture you, fits on the page, and gives you the right answer. So I'm going to go with the eliminating C's. So I'm going to do the opposite of row 1, which would be 1 equals -A minus B minus C. And I'm going to add it to row 2, which I'm just going to copy. And that would get the C's to drop out. And then there are different ways to do this, but I kind of so I have a positive B here. I'm going to aim for getting a negative B in the next one. So I'm going to go ahead and do row 2 and negative row 3 for that. So the opposite of row 3, keep in mind you have to involve all the rows at some point or you'll end up with like infinitely many solutions type stuff, and you don't want that. That would be misleading. So I'll do the opposite of row 3 and I'm going to add it to row 2. Let's see if I got what I wanted out of this. I did. There we go. So I got the C's to eliminate. And with my new equations here, I have to use the elimination again. And it'd be really easy for me to just add them together to get the B's to eliminate out. Like I said, there are different ways to do this. I'm just trying to demonstrate something that would be really efficient for you. Just in case you still have a tendency to kind of torture yourself with algebra with these. Anyway, so when I add these two equations together, I ended up with this expression, and I could just divide both sides by -2, and then I'd know that A was positive 5/2. So congratulations if you got that one way or the other. And then now that I know what A is, I could back substitute into either of these equations. I kind of like this equation, I guess. So I'm just going to put that back into equation 1. So it would tell me that 1 is equal to 3 times 5/2 plus B. Make sure you treat the 3 like 3 over 1 when you multiply these together. So you'd end up with 15 over 2, and then 1 is like 2 over 2, so you subtract it over, and you'd end up with B equaling -13 over 2. Now it's just a matter of finding C, and I really like this equation, this row 1 up here, the most. For that, you could have substituted into any of the original 3, though. And so to get C, I would just put it in up here. So I'd have -1 is equal to A, which was 5/2, plus B, which would be like subtracting 13 over 2, and then plus C. And then just simplify this. Let's see, what is that? -8/2 right there, which would be -4, and then you'd add it over. So it looks like C is 3. There we go. And then your final answer then would be this expression right here, just completed with the A, B, and C values that you found. So your nth term can be calculated by taking 5/2 and multiplying it by n squared, whoops, and then subtracting 13 over 2 and multiplying it by n, and then adding 3. There we go. Okay, if you need to hear about partial credit on this one, here is your partial credit. So you're going to get 2 points for plugging in 1 for n and getting -1 out for a sub n, and then simplifying your equation to this. 2 points for doing the same thing with n equaling 2 and a sub 2 equaling 0, so putting 2 and 0 in simultaneously and getting to here. 2 points for plugging 3 in for n and getting 6 out. So right there, out of the 10 points, you've already earned 6 of them. And then the other points are for accuracy. So 1 point for getting 5/2 for A, 1 point for getting -13/2 for B, 1 point for getting 3 for C, and then your last point, and you could get this even if you have the wrong answer based on kind of, or you have, yeah, so you did the right thing with wrong answers. So whatever you got for A, B, and C, showing that you knew to put those into the original model for your final answer is worth the final point there. There we go. Okay, now I think in the next video about the bonus problem, I'll show the shortcut for how to do problem 4, and then how that really could have helped you down here for the bonus problem. Stay tuned.